Hey guys, how's it going? This is Mr. Dorado here again with another video lesson for you guys. This is actually the start of chapter 4, okay? So we are going to go ahead and talk a little bit about inequalities. Now, you may or may not be familiar with inequalities. They're very similar to equations, okay? So linear equations with a few differences. Okay, so let's go ahead and talk a little bit about what those differences are and how we can identify these inequalities. So we're going to go ahead and start off with this first symbol here, which is actually the less than symbol. Okay, so that is the less than symbol, which means that this other has to be our greater than symbol. Okay, you guys should be pretty familiar with those symbols by now, but if not, just remember this less than symbol. If you guys notice, if you make a capital L, okay, with your, actually you can also do it with your left hand, in between your index finger and your thumb. You see how you kind of make an L, and that one looks more like this symbol right here rather than that one. Okay, so that's how you can always tell which one's your less than symbol. Okay, and just to be clear, it'd be something like this. So 3 is less than 4. Okay, so see how it kind of makes an L? That's how you know that's the less than symbol, which means that the other, which goes the opposite way, would be our greater than symbol. So 4 is greater than 3. Okay, now the only difference between this one on the left here and this one on the right is that this one has a little line underneath. That just means it's a less than or equal to symbol. Okay, so it's less than or equal to, meaning that this other one that has a little line underneath is also a greater than or equal to. Okay, so then let's see what we have up next. Now, open circles are used for the signs less than and greater than, and closed circles are used for the signs less than or equal to or greater than or equal to. Now we will make sure that is a little more clear in a second, but basically what that means is that on a number line, when we're doing these inequalities, we show an open circle when it's just less than or equal to, or we use a closed circle, which is just a filled in circle for when we have less than or equal to or greater than or equal to. So let's go ahead and take a look at number 1, the first inequality we have here. So we are given that x is less than 2. So x is less than 2. So that's all we're saying on that particular inequality. Now we actually have to go ahead and draw it, okay? So because we're looking at the number 2, I'm actually going to make that the center point there. Okay, now we actually have to figure out which way we are shading. Now, the reason why we're shading is because this inequality, or actually for many inequalities, if not all, we are actually looking for a solution set. So we don't just have one answer like x equals 2, x equals 5, x equals negative 10. And we actually have a solution set, so we have multiple solutions, okay? This is telling me in words x is less than 2. So there is some number x that is less than 2. So in your head, can you think of a few numbers that are less than 2? Well, 1, 0, -1, -5, -10, -1,000,000, okay? There's a ton of numbers that are less than 2. So what we're going to do is represent that using this this line right here, okay? So this real number line, we're going to go ahead and represent x is less than 2, and we said that less than uses an open circle. So right here on my 2, I'm going to do a open circle, okay? And then let's think about it. Which way should I shade? Well, further to the left here, I would have my values that are smaller. And further to my right, I would have values that are larger. Just like the number line that we started studying back in grade school. Okay? So let's go ahead and see if we can figure out which way to shade. Well, all the values that are less than 2 are actually on the left. So I'm going to go ahead and shade to the left. Okay, so I shaded everything to the left, and then this arrow keeps going further because all those numbers on the left side would also be less than 2. Okay, now I'm gonna actually show you guys a quick trick here on how to graph and how to remember which way you need to shade. But let's go ahead and look at number 2 for a second first. So let's go ahead and see. We have -3 is less than y. Okay, now honestly, you're going to ask a lot of math teachers if they'd prefer this form or they prefer this form. And those math teachers are probably going to tell you they like the second form better. And I'll explain why. The reason why the second form is actually a little better is because if we keep something consistent, we'll always get consistent answers. Meaning, if we always make sure we have the variable on the left side, we can make generalizations and we can make rules for certain things and even shortcuts. Okay, so how did I rewrite it? Well, let's look at this. Pretend right here we had a Pac-Man, right? Hopefully that looks like a Pac-Man. Well, which number is it eating? Is it eating the -3 or is it eating the y? Well, it's eating the y, right? The mouth is open towards the y. So here, my mouth is still open towards the y. So those two are exactly identical. Now, let's go ahead and actually graph that. So once again, let's take my numbers here, which is -3. I'm going to make that my center value, a -3. And once again, we have well, actually now we have a greater than sign, but again, even the greater than sign still requires an open circle. So I'm going to go ahead and do an open circle yet again. Okay, so I did an open circle, and it says y is greater than -3. Y is greater than -3. And just to be clear, let's remember our number line. We always draw values that are larger to the right and values that are smaller to the left. And I can keep going. I'm not going to go ahead and draw all of them. So let's think, which y values are greater than -3? Well, all the ones on the right-hand side. So I'm going to go ahead and actually shade to the right-hand side. All of these other values on the right-hand side are greater than -3. Okay, and if you want, go ahead and think to yourself, is 1 greater than -3? Yes, it is. Is 2 greater than -3? Yes, it is. Over here, we would have something like, I don't know, 10. Is 10 greater than -3? Yes, it is. Okay, so we are on the right track. Now, the reason why you want to get in the habit of actually writing or rewriting, if you have to, the variable on the left side first is because the way the arrow is pointing on your symbol is actually the way you have to shade. Now, that's a quick little trick, and if you want to use, you are more than welcome to use. You don't have to. You can always actually read this out loud, read your statement out loud, and then you'll determine which way you have to shade. But if you notice, and I'll show you right here, if you notice on this number 1 equation, look at, it says x is less than 2. This less than symbol kind of looks like an arrow that's pointing to the left, correct? Well, it's pointing to the left, and look at where I shaded. I shaded everything to the left. What about right here? Remember how I rewrote number 2? So remember how I rewrote number 2 as y is greater than negative 3? Well, look at that. Doesn't this kind of look like an arrow going to the right? And which way did I shade? I shaded to the right. Now, that only is true because we always want, if we always have the variable on the left side of the inequality, then you can follow that shortcut. If not, then you absolutely cannot do that. It only applies when you have the variable on the left side. So let's make sure that is true. Let's go ahead and try out number 3. So we have a is less than or equal to negative 4. So just like before, make whatever number you're graphing the center value. And if you want, maybe write like 2 values that are less than that and 2 values that are greater than that. I'm actually going to do a third value here. Okay. So what do we have? Less than or equal to? That means we have to have a closed circle, right? We're actually including 4 as a possible solution. Okay. And then which way? Well, let's see. Which way do we have to shade? Notice that the a is already on the left side. It's already in the form we wanted in variable, the inequality symbol, and then the number. Okay, so actually if we want to think of this as an arrow, we can go ahead and do that. Look, this arrow is kind of pointing to the left, so we want to shade everything to the left. Okay, so this is just another way of me shading. You could shade it like this if you want, just like I did earlier. It doesn't matter. Okay, again, if that doesn't convince you why we can do this little shortcut, then just think to yourself what this inequality said. So I'm going to go ahead and erase this for a second. This says a is less than or equal to negative 4. So is negative 4 less than or equal to negative 4? Yeah, that's why it's right here, right? That's why we circled it, because negative 4 is less than or equal to. It's actually equal to negative 4. Now, is negative 5 less than or equal to negative 4? Yes, it is. Is negative 6 less than or equal to negative 4? Yes, it is. And all other values, even like negative 100, that is also less than or equal to negative 4. However, anything on the right, okay, negative 2 is not less than or equal to negative 4, so we would not shade that part. Okay, so you have two methods of doing this, guys. You can actually write it out and think to yourself, which way should this arrow be pointing or which way should I be shading? Or go ahead and look at your symbol. If your variable is already on the left side, then you could pretend that's a little arrow, and that'll tell you exactly where to shade. I'm going to go ahead and do number 4 and 5 with you, and I want you guys to try out 6, 7, and 8 on your own. So let's go ahead and take a quick look at number 5. Number 4. So we have 5 is less than or equal to x. Well, I noticed right away that I have my x on the right side, but I want it on the left side. So I'm going to rewrite it as x, and then a 5 here, and I want to see which way do I have to have my inequality symbol. Well, again, if it helps, draw a little Pac-Man here. And that's a horrible little Pac-Man. Let's try that again. Okay, that little Pac-Man looks like it's actually eating my X, so I have to draw another Pac-Man that is eating my X. And just remember that this is less than or equal to, so when I flip it, it becomes X is greater than or equal to 5. So these two now are equivalent. Okay, they're exactly the same. Okay, another way you could think of it, if you're not sure why I'm even doing a little Pac-Man, just think of it this way. Which way is this little arrow pointing toward? It's pointing towards the 5, right? The tip of it is at the 5. Okay? So when I rewrite it, my tip here has to be towards the 5, which it is. So then those two forms are equivalent. Okay. Let's go ahead and draw my 5 in the center. Again, if you want, draw some numbers here that are less than 5 and some that are greater than 5 to the right. Always remember, to the right is positive, to the left is negative, so that way you know which ones are smaller and greater than 5. And because it's a x is greater than or equal to 5, we have to have a shaded circle, a closed circle at 5, because we're including that in our solution set. Excuse me. And then we also have to shade, well, which way now? I'm going to go ahead and do the other method now. Think of this little symbol here as an arrow, so it's pointing to the right, so I'm going to have to shade to the right, which totally makes sense because when you think about it, this says x is greater than or equal to 5. So values that are greater than or equal to 5, well, 6 is definitely greater than or equal to 5. 7 is definitely greater than or equal to 5, and so is 8, and so on. All right, last one I'm going to do with you guys, and then you guys are off on your own to try out 6 through 8. So c is greater than -6, so right off the bat, let's do our -6. Now the c is already on the left side, so it's good to go. If I pretend this is a little arrow, see how I can't even draw with my pen here, but look at that. It looks like an arrow that's pointing to the right, so I'm going to have to shade to the right. Okay, and it didn't have an equal to sign underneath it, so it has to have an open circle. So let me make that a little more clear that it's an open circle here. It's an open circle, okay? And let's see. Let's test it out. Let's make sure that we shade it to the right side. So if this is true, then I don't know. What do we have over here? A -5, -4. We can make a few more points and even 0. Okay. And to the left would be like -7, -8, -9. Okay. So if it's true, then something in our solution set, which is the stuff that we shaded, like for example, this point 0, I should be able to put that into where my C is and verify if it's true. So let's try it. Is 0 is 0 greater than -6? Well, yeah, because 0 is neither positive or negative. So, but it is closer to the positive side than -6 is. So yes, 0 is greater than -6. Hence, this is true. So we did shade to the right side. Now let's actually test out one of these other points to see if that would have worked. Let's test out -9. Is -9 greater than -6? Well, is -9 greater than -6? No, -9 is way more negative than -6. So this would not work. So it looks like we are on the right track. All right, so go ahead and take the time right now to pause the video and try out number 6 through 8 for me, please. All right, let's go ahead and try out 6 through 8. So again, start with your number that you have there. Its x is less than or equal to 4, so we definitely have to shade or close this circle, right? Now, which way are we shading? Well, the x is already on the left side, so it's good. And which way is this little arrow pointing? This little arrow is pointing to the left, right? So we should be shading to the left. All these points to the left. Now, again, if you want to try it out, let's try it out. Let's verify that we have done this correctly. So to the left would be the numbers that are smaller, so it'd be like 3, 2, 1, 0. Okay. To the right would be numbers that are larger, so 5, 6, 5, 6, 7, 8. And I'm going through this pretty quick, so my numbers look horrible, so sorry about that. Okay. But let's try this out. So let's try a few of these numbers that are in my shaded region. Well, I see 2's in my shaded region, so is 2 less than or equal to 4? Is that a true statement? Yes, it is, so it checks out. Let's try another one. Is 0 less than or equal to 4? That is also a true statement, so it checks out. Now let's try some over here. On the right-hand side, is 6 less than or equal to 4? Nope. Is 8 less than or equal to 4? Nope. And that's why we did not shade to the right. Okay, the next two, I'm just going to kind of fly right through them. So I don't like how this one's written because it has the 0 first and then the x. I want the x first, so x and then 0. So which way do I have to redraw my symbol? I have to redraw it like this. We want the mouth opening towards the 0, just like my Pac-Man is right there. Okay? So this is my new inequality. Start at 0. It says x is less than 0. Okay? And notice again my little arrow here. It's kind of like it's pointing to the left. Okay, so I'm going to have to shade to the left. All right? Again, test out a few points, guys, if you need to. It's totally fine. That's the whole point of this. We're trying to gain a little bit of conceptual knowledge here, not just understand the procedures. We're trying to understand why that's true. So let's try out a few values. What values would be over here? Like -1, -2, -3. On the right-hand side, we have like 1, 2, 3, so all the positive values. So let's test out the area that we actually shaded, this right here. So let's try out maybe -2. Is -2 less than 0? Yes, it is. Is -3 less than 0? Yes, it is. Is -1 less than 0? Yes, it is. So these three definitely check out. Okay, and obviously the ones on the right would not, but you can always double check. Is 3 less than 0? Nope. Is 4 less than 0? Nope. Is even 1 less than 0? Nope. None of those are correct, and hence you do not shade on the right-hand side. The only thing that I did forget, that try not to forget from now on, guys, is that x is less than 0. There is no equal to sign, so it has to have an open circle. Okay. Last one, y is less than -5. That one's already kind of a nice format. So I'm going to do my -5. It's just less than, so it doesn't require a closed circle, so just an open. And then which way should I shade? Well, if I remember my little rule there, I have to shade to the left because it looks like the arrow is going to the left. Okay. Now, 9 through 14. Slightly different, not too hard. Now we're being asked to write the inequality represented on the graph. So for this, why don't you go ahead and just use x as your variable? I mean, you can use y, you can use whatever you want, but for now, let's just go ahead and pretend this is an x. So what I like to do, and if it helps, try it. If something different helps, then try something different. I like to write the two things that I know I have. Like we said, we're going to pretend that we're going to have x, so I'm going to put an x, and I always like to have the variable on the left, so I'm going to put the variable on the left right away. And there's also a -3 here. Okay, so because there's a -3, that's why I'm going to put a -3 over here. So my x on the left, a -3 on the right. Now it's just a matter of what symbol do we use? Well, notice that I have an open circle, so my only choices are less than or greater than. I cannot use less than or equal to or greater than or equal to. Only less than or greater than. So let's see. Again, you have two choices. You can either ask yourself what numbers would be on this shaded region. Well, it would be -2, -1, 0. Now, is 0 less than -3 or is it greater than -3? Well, 0 is greater than -3. And again, look at this, guys. This is an arrow, right? And what symbol is that I just drew in orange there? That's a greater than symbol. Hence why I have a greater than symbol there. Okay, so hopefully that's starting to make sense, but let's go ahead and try out a few more. So once again, I know right off the bat I have a 7 there, and I'm going to use x as my variable. So x on the right, on the left, 7 on the right. So straight off the bat, I'm going to do that. Now I have to decide what symbol I'm going to use. Well, it's a closed circle, so I'm going to either use less than or equal to, or greater than or equal to. Okay, so which one do I use? Well, let's see. Which way is this shaded region arrow pointing towards? Well, look at that. It's pointing to the left, and what symbol does that red symbol look like? It looks like a less than symbol, so it should be a less than equal to. So this one is not the one we want. We want that one. Okay, x is less than 7. And again, think about the shaded region, guys. Everything to the left is smaller than 7. Like for example, 4. So test it out. Is 4 less than or equal to 7? Yes, it is. Hence why x is less than or equal to 7 is correct inequality that represents that graph. Okay, let's go ahead and do 11, and then you guys are doing 12 through 14. So for 11, we have, again, write your x, your -9. Now let's decide what symbol to use. It's an open circle, so we only have two choices, less than or greater than. Well, which way is this pointing? It's pointing to the left. And if you notice that what I just shaded there in purple looks like a less than symbol. So x is less than -9. Test it out. On the left side should be the numbers that are less than -9. So like -11. So try one out. -11 less than -9. Is that true? Whoops. Yes, it's true, and hence we got our symbol correct. So x is less than -9. Okay. Go ahead and try out 12 through 14. So pause the video, and then we will go ahead and continue with these problems. All right, guys, let's go ahead and take a look at 12. So again, write your x and your -6, always your variable on the left and your number on the right. Now let's identify what symbol we have to use. Well, it's a closed circle. So which symbols can we use? Either a less than or equal to or a greater than or equal to. So which is it? Well, again, my arrow is going to the left. So what symbol did I just draw in? I drew in a less than sign. And remember, it's less than or equal to in this case. And remember, you can always test out a point. So go ahead and test it out if you need to. Next one, x and 5. It's a closed circle. Hence, I can only use, whoops, sorry about that. Hence, I can only use less than or equal to or greater than or equal to. Well, which one is it? Well, again, here on my shaded arrow, I have that. So what I shaded here is a greater than symbol, and because it's shaded, because it's a closed circle, then I have to do an equal to sign. Okay, so that's the one we needed in this case. Last one, yet again, x, and that number I see there is a 1. Let's figure out what symbol. Well, two choices, less than or greater than, because there is an open circle, so you can't have the equal to signs. So let's see. The shaded arrow is over here. So what symbol did I just make there? I made a less than symbol. So x is less than 1. Again, if you would like to test out a few points, guys, by all means do so. Is -1 less than 1? Yes, that is true. So I did the correct symbol. Now you might be asking, and maybe I should address this before we keep going, how am I substituting, or where am I getting -1 is less than 1? Well, it's right here, guys. -1 is right here, correct? That's in this really dark shaded region of black on my number line. So that means that is part of my solution set. So if this is in fact the correct equation right here, okay, if this right here is my correct, I'm sorry, not my correct equation, my correct inequality, then I should be able to substitute that -1 into my x. Okay, and that's what I did. So all of this, I substituted the -1 into my x to get this inequality. -1 is less than 1. Is that true? Yes, it's true. And so this inequality right here is correct. X is less than 1. Okay, we can keep going now. So, when we're solving equations, okay, we have a very simple way of doing it. I have x plus 6. The whole goal here is to isolate x. Now, we isolated how? Well, we've done it before. SADMAP, right? Okay, we want to solve for x, so we're using SADMAP. So get rid of any addition and subtraction first. Let's subtract 6. I get x equals -4. Simple enough, but no. Now, notice, this right here, if I put -4 on the number line, that's right there. What is my answer here telling me? Well, it says that x equals -4. So the only number that works is -4. So do I even have to shade to the left or right? Well, no, because it's telling me the only number that works, remember, one solution, right? It's only one solution. Only -4 works. Okay? So this solution is a, oops, it's just a number. Okay? That solution is just a number. Okay? Now, over here on when we're solving inequalities, we're going to do something similar. But instead, we're going to, once again, let's go ahead and solve using SADMAP. So we get x is less than, keep the symbol exactly as it is, don't change anything, is less than -4. So once again, I'm going to go ahead and draw -4 on my number line. But now notice, this is an inequality, okay? I have x is less than or equal to -4. Because I have a less than or equal to, it's definitely a closed circle, just like the equation. However, it's also less than, which means I have to go ahead and shade a solution set. So the solution is a solution set. Okay? It's a set of values that satisfy that particular inequality. Okay? So it's x is less than or equal to -4. So what numbers are less than -4? Well, over here is -5, -6, -7. All those numbers are less than. And again, if you remember my little trick, this arrow right there looks like it's pointing to the left. So I have to shade to the left. So what's the difference between those two problems? The problem is very similar, except the difference is that one has a plus, I'm sorry, one has an equal to sign and one has a less than or equal to sign. Okay, so inequalities give you solution sets. Equations gives you a number for a solution. Might be one solution, no solutions, or all real solutions, depending on the case. But usually you will have just a number as your solution. But this chapter is concentrating on inequalities, so let's go ahead and continue practicing with some inequalities here. So we have x divided by 4 is less than or equal to 1. Well, just like before, we undo this division by 4 using the inverse operation, which is multiplying by 4. So we get x less than or equal to 1 times 4 is just 4. Again, notice how I kept the same symbol. I didn't change the symbol at all. I kept the same symbol. And just to make that a little more clear, let me actually rewrite this so that you can see that a little clearer. Okay, notice between the top part and the bottom part, my symbol is still a less than or equal to. Okay? All right, so let's go ahead and graph this. Okay, so I'm going to go ahead and write a 4 right there. Okay, and then I'm going to actually shade it. Well, why am I shading, guys? Well, remember, Remember that I have an equal to sign there, so I have to make sure I shade. Now that little arrow or that less than symbol looks like a very, it looks like an arrow and it looks like it's pointing to the left. So I'm going to go ahead and shade to the left. Okay, so my solution here is just x is less than or equal to 4. Okay, all right, let's go ahead and try out number 16. So for this one, we actually have a specific rule, and I'm going to actually tell you guys the rule in a second, and we will go ahead and prove it a little bit later on in this video. But let's go ahead and try it out. So how do we undo that -4? It's been multiplied originally, but now I'm going to divide it. Okay, so what happens here? Here I'm going to write x, and now instead of a greater than symbol, I'm actually going to flip it. I'm going to do x is less than. Now what's 20 divided by -4? That's a -5. Okay, so what is that rule? I'm going to go ahead and do it in the little cloud here. So you must flip the inequality sign. So flip the sign if you multiply or divide by a negative number. Okay, so you must flip the sign if you multiply or divide by a negative number. Now, I don't have any room here to go ahead and show you a quick example of why that's true, but I'm going to show you at the end of the video, okay? So, for now, let's just go ahead and continue with that. So here I'm dividing by -4, so what do I have to do? I have to flip the sign. Now, instead of it being greater than, it has now flipped and turned to less than. And 20 divided by -4, which is -5. So my solution here is x is less than -5. Let's go ahead and graph that. I have a -5. It is an open circle because I have just a less than, not a less than or equal to. And that less than symbol looks like it's pointing to the left. Right? The little arrow kind of looks like it's pointing to the left. So I'm going to shade to the left, because all the numbers here on the left side are less than -5. Okay, next one. Number 17. -1/3 a is greater than 2. How do we get rid of a -1/3? We multiply by its reciprocal. Remember, we always multiply by a reciprocal, which is -3/1, or just -3. And what did we just do? So again, that cancels these out, so you're left with a, but we just multiplied by a negative number, and our rule that we just wrote up top says that we have to flip our sign. Instead of being a greater than, now I'm going to have a less than, and 2 times -3 is a -6. So let's go ahead and write that as my solution. That's a solution set. Okay. And so, if I graph it, we're going to have an open circle. Okay, because it's just a less than symbol, and it's going to point to the left because that's the way my symbol is pointing, right? It's pointing to the left. If you notice this right here that I just drew and this are exactly the same, okay? So I'm going to go ahead and shade to the left. And we have graphed that inequality. Okay, next one. 49 is less than or equal to 7b. Well, I don't want that 7. I want to get rid of it. So I'm going to divide both sides by 7. It's a positive 7 that I'm dividing by, so I don't have to flip. So that's why I kept the exact same symbol. Okay? But remember, I want my variable always on the left side. So because I want my variable on the left side, then I have to rewrite it as b. And then now, remember my little Pac-Man here? It's eating the b, so I have to draw it eating the b. And then I have to go ahead and write in my 7. So technically we're not flipping. Well, I guess I should say technically we are flipping, but we only call it a flip if we're dividing or multiplying by a negative. Okay? This I'm just literally rewriting. So instead of calling this a flip, I would call this a rewrite. Okay? Basically the same outcome. The symbols flip, except for not really, because they're still essentially pointing the right way. It's just that we moved the b and the 7 around. So I'm technically just rewriting it. So my answer here is b is greater than 7. Go ahead and put my 7 down. It's a greater than, so it doesn't need to be closed. It's just open. And again, my arrow right there, or my symbol, is pointing to the right, just like this one. So I'm going to be shading to the right. Okay? Last two, guys, I want you guys to try them on your own. So number 17 and 18, go ahead and pause the video and try them out. Alright guys, let's go ahead and do number 17. So negative 2/3, remember we don't like dividing fractions, so the way we're going to get rid of it is by multiplying by its reciprocal, which in this case would be negative 3/2. So we have to do the same thing on the other side. Well, these now go away, you're just left with a, but remember, what did we just do? We multiplied by negative 3/2. So we're going to have to flip. We multiplied by a negative number, so now instead of a less than, it's a greater than, and 6 times negative 3/2 is actually a negative 9. So a is greater than negative 9, so go ahead and draw your negative 9 there. It is a open circle because it's just greater than, and again, this right here is pointing to the right. So I'm going to shade to the right. Okay, so again, my solution here was just a is greater than negative 9. It is a solution set, so there's multiple answers here. This is an answer, this is an answer, this is an answer, this is an answer, and goes on forever. Okay, last one, guys. So make sure that you had your answer correct for number 17. Now let's go ahead and try number 18. So similar stuff. We're using SADMAP, so get rid of any addition and subtraction first. Now, here I am not going to change the symbol. Why am I not going to change it? Because I'm subtracting a 7, not multiplying or dividing by a negative number. Okay? I'm just subtracting a 7, so nothing changes. So I get 2x is less than 6. Last step, divide by 2. That yet again is a positive number, so I don't have to flip. So once again, I keep my symbol. I get x is less than 3. So my solution is x is less than 3. I'm going to draw a 3 there. Open or close circle? Well, this one is a open, okay, because it doesn't have that little bar underneath, no equal to sign. And again, this less than symbol looks like an arrow pointing to the left, just like this one is pointing to the left. So I shade to the left. Okay, guys. Now, last thing I want to do here, and I think I am going to have to scroll back up to number, actually, let's take a look at number 17 real quick. I think we have quite a bit of space here that we can use. Okay? Now, I want to do this for you guys because I feel it helps to understand why these rules happen rather than just taking them for granted and saying, oh, okay, that's a rule, so I have to follow it. Okay, well, no, there's more to it. There's a reason why we have to follow it. So let's actually try this out. Okay, so I'm going to take number 17 as an example. Okay, in number 17, we had to flip. Okay, so I'm going to write it. We had to flip. Let's pretend for a second that I didn't flip. Okay, let's pretend a second that I didn't flip. So my answer would be A is greater than -6, right? Because for my answer, my real answer was A is less than -6, but if I didn't flip, it would be A is greater than -6. So what I want you to do right now is think of a number that's greater than -6, okay? And actually, just to make sure there's no argument, let's see, is 6 greater than -6? Yeah, right? 6 is greater than -6. So why don't we make 6 one of our test points? Okay? So if this is true, and if our solution really was A is greater than -6, okay? If we start to think that we shouldn't have flipped, and this really is our answer, then I see no reason why I can't substitute in 6 into our variable A, okay? And still get a true statement. So if that's true, we should get a true statement. Well, let's go ahead and try it out. My original equation was -1/3, and now instead of an A, I'm going to put that 6, because we said that 6 is definitely greater than -6, right? We agreed on that. So 6 is something I'm going to use here. And if I continue writing my inequality, okay, I think I've been saying equation for some reason, so I apologize. I apologize if I have. This is an inequality. There's no equal signs here, so we can't say equals. Okay, so -1/3 times 6. Well, what is that? That's a -2 and a 2, right? Well, is this true, guys? Is -2 greater than 2? No, it's not. That's a false statement. This is absolutely false, okay? Because that's false, then this has to be false, okay? Which means that this right here, that we indeed did have to flip, okay? Because if we hadn't flipped, then we would have gotten this answer right here. A is greater than -6. But we just proved that it doesn't work. Now, if that still doesn't convince you, let's think of another number. Let's pretend again this really is our answer. Okay? Let's pretend that's our answer. A is greater than -6. Think of another number that's greater than -6 that we could try out. Well, I'll give you guys an easy one. Isn't 0 greater than -6? Okay? Or, yeah, is 0 greater than -6? Yeah. Well, it's true. Let's try it out. Is 0 greater than -6? Yes, it is. So 0 is a potential new solution. And I'm sorry if this is getting cluttered here, guys, but I just want to make sure I get the point across here. Now, if that's true, if 0 is greater than or equal to, greater than -6, then I see no reason, just like before, that I can't substitute this 0 into my original A. So let's do it. -1/3, let me do a little line here, -1/3 times 0 is greater than 2. -1/3 times 0, well, anything times 0 is just 0. So we get, as a final answer after we checked, that 0 is greater than 2. Well, that's not true. That's false. This, yet again, is false. That is not true. That would not work, okay? Now, that's, again, telling us that we definitely needed to flip, okay? So our answer in actuality is what we had when we did this problem the first time around. It is A is less than -6. Okay, and again, I see this all the time. people still don't seem to understand why that's true, or how do you know that? So again, let's pick a number in this thing that we know now has to be the answer, right? This a is less than -6. What is a number less than -6? Well, how about I pick -9? Is -9, here, let's do this. Is -9 less than -6? Yes, that's true. So there's no reason why I shouldn't be able to put -9 in here and get an answer that is correct. So let's see, -1/3 times -9 is greater than 2. Well, I'm running out of space here, guys. So I'm actually going to do this down here. Is -1/3 times -9, what is that? Well, that's actually a +3. And then again, greater than 2. Is 3 greater than 2? Yes, it is. And once again, proving that this answer here was correct. We did have to go ahead and flip. Okay, so we did have to go ahead and flip, hence our answer is a is less than -6. Okay guys, so again, I went a little further than I probably should have. However, that is the way I like to teach, guys. I like to make sure that my students understand where these things are coming from. Don't just take them for granted, guys. If something doesn't make sense why you're doing a particular rule, ask. Get an understanding of why you're doing something, okay? If you do, everything else becomes so much easier, okay? All your answers, you're able to check them a lot easier, and hence you're able to get better grades on tests, quizzes, and even on your homework. You're able to do a much better homework, okay? So I think I'm going to go ahead and end the video here for now, guys. So I hope you guys had a good time watching this video. I know sometimes it's not as fun as you might think, but it definitely helps you guys understand a little more in order to make sure you guys do well in your algebra class. Alright guys, so I will talk to you guys soon, and hopefully you guys are ready for 4.2. Alright, see you guys.